Alright, so today what we're talking about is the median and the centroid. Now, there's a movie from my childhood called Treasure Planet. And there's this really weird robot. He's very strange. And he's literally lost his mind, like his memory chip, he's lost it. And he starts talking about something called the centroid of the mechanism. Now, if you've ever seen the movie, you will know that the centroid of the mechanism is the center of the planet being the mechanism. So the center of the planet, they call it the centroid because it is the center of gravity. Now, the center of gravity is kind of cool because it's that balancing point. So we can find the balancing point of a triangle by connecting all the medians. Now, we need to know what a median is. A median of a triangle is a segment whose endpoint is the vertex and the midpoint of the opposite side. In other words, you take it from the point to the middle. Okay? So the point to the middle, that line is called the median. So the point to the middle of the opposite side. Not the middle of the same side because that doesn't make sense because then it'd only be half of a line. So we actually want to go through the triangle. Now the cool thing about the centroid is because it is the center of gravity, is that we'll always be inside the circle. So end center is always inside the circle and centroid is always inside the circle. Centroid being the center of gravity or that balancing point. Okay? So it's really cool about this is that there's something called, I call it the thirds rule. It's that the balancing point of a triangle, is always 2/3 away from the point. So if you consider that to be 2/3, then it's only 1/3 of the way of the side. And that makes each line, and this is true of all of them, so like it would be 2/3 away from y and 1/3 away from the line opposite y. It's 2/3 away from x, and it's only 1/3 away from the line opposite x. Okay, it's the thirds rule. So if I think of a line, so like this is my line YA, this being the point, this is my vertex, or that point. 2/3 of that line is going to be from the point to the centroid. Then 1/3 of that line is going to be from the centroid to the side. Now this makes sense for a balancing point because if you think about it, the majority of the mass is going to be closer to the sides of the triangle than it will be the points of the triangle. Okay? I don't have like a physics degree, so I can't explain it really in more concise terms than that. But that's the way I think about it. If you go towards the tip, you have less and less mass, whereas if you go towards the side, you're going to have more mass. Okay? So 2/3 to 1/3. So this is how I think about it. The whole line is 3 parts. From the point to the center is 2 parts. From the center to the side is 1 part. If you add the 2 parts and the 1 part together, you get the whole 3 parts. Okay? Now we're going to practice this 2/3 rule. So right here it tells me that y to u, so this, is 3.6. Now I need to decide, is that the whole line? So 3 parts go to the whole line. Is it 2 parts, which goes from the vertex to the center? Or is it 1 part, because it's from the center to the side? Okay? Now, if I look at yu, that's 2 parts because it's from the vertex to the center being y. So 3.6 is equivalent to 2 parts. So if I want to find zy, well, zy is only 1 part, so I need half of 3.6. So 3.6 equals 2 parts. So if I want 1 part, then I take 3.6 and I divide it by 2. So that's 1.8. Okay? And then if I want zu, which is 3 parts, I can take my 2 parts and my 1 part and add them together. That should give me all 3. So I take 3.6 plus 1.8, and I get 5.4. You can also get this by multiplying the 1 part by 3, because that would also give you 3 parts. But that's how I find that. Okay, so I took the 2 parts, I broke it in half. This is me breaking it in half to get 1 part. And then you've got two ways to find the 3 parts. You can either do 1.8 times 3, take one part and multiply it by 3, and that'll give you the 3 parts. Or you can take 3.6 and add 1.8 to get 5.4. Okay, both ways end up with the same answer. I want you guys to go ahead and practice on these two. So both of these are using the same triangle that's in the bottom right. And once you finish practicing those, you can go ahead and write your recap. Please do the learning activities so you can practice this a ton so you can feel really confident about it. This is probably my favorite center because we're talking about the center of gravity, and I see a lot of applications of finding the center of gravity of a triangle. It makes sense to me. So I hope you have a good day.